purpose of this video is to consider the concept of conditional probability. But before beginning, I want to do a quick review of joint and marginal probabilities. So when you think about joint probabilities, we might represent them like this. PSH, which means probability that the random variable S, capital S, would take on a particular value, lowercase s, and the random variable, capital H, would take on a particular value, lowercase h, when the experiment was done. And the whole idea is the term we used was and to define this relationship. So what we have here is the species would be some particular value and the height would be some particular value. The other thing is these joint probabilities were found in the body of the probability table. So that was joint probabilities. And then we had marginal probabilities, which for example we might represent as P, capital S, lowercase s, which would be equal to the probability that the random variable uppercase s would equal some particular value lowercase s when the experiment was done. And these values were found in the margin of the table as opposed to being in the body of the table. And so with that review, I want to now move on and consider the concept of conditional probability. And perhaps the best way to approach this is with an example. So what I want to do is I want to evaluate the probability that a tree is a pine. And now the operative word is given that its height class is greater than 170 centimeters. So we can represent that as probability S equals 2 given H equals 1, or P So again, we're just doing notation. So what this idea of conditional probability is, and what's important is this vertical line. Because this vertical line means given. So the probability that the random variable S is going to take on a value of 2, given that the random variable H has a value of 1, we can represent it like this in a general sense. Or in this particular case, the probability of being a pine, in other words, S is equal to 1, is given that it's in height class, S is equal to 2, given that it's in height class 1. So if we come to this table here, which is a table of counts, we can see how we would answer that question. So we know it's given that the height is greater than 170 centimeters. So we're now operating in this particular row. And now we want to know, given that we're in this particular row, what's the probability that a randomly selected tree is going to be a pine? Well, looking at this table now, we can see the answer is pretty obvious. There's 450 trees that have a height greater than 170 centimeters, 100 of which are pines. So therefore, the answer to our question is 0.22. Now, we don't have to use this table of counts to answer that question. Now we've got the table of probabilities here, but let's just reflect upon what we did earlier. What we did earlier was we took this value, 100, and we divided it by this value, 450, to get this value. And now what we're going to do is we're going to just repeat that process using the probabilities. We're going to take this value, 0.1, divide it by this value, 0.45, and that's also going to give us 0.22. So now let's go back and think about some of this notation. What we're trying to do is we're trying to calculate the probability of a tree being a pine given, and the vertical line's important, that represents given, that its height class is greater than 170. And what we're saying is the way we're going to get that is we're going to start off with the joint probability. I'm going to start off with this joint probability. The probability of pine and greater than 170. And then we're going to divide by the marginal probability that it's greater than 170. So that's what we've done here. Taking the joint probability, divided by the marginal probability, and that's what gives us our conditional probability. So again, some more of this nasty notation. What we're saying is probability that the random variable S is going to take on a value of 2. In other words, it's going to be a spruce, given that the random variable H, representing height class, is going to be a 1. We can represent that as being equal to a joint distribution. So we notice the comma here, it's a joint distribution divided by the marginal distribution present this as probability that H is equal to 1. Okay, so another way to represent this, another set of notation, is to say P, this is a little bit more simplified, SH is equal to P So again, the probability of a randomly selected tree taking on a particular value of species, given that we know that it's got a particular value of height class, we start off with the joint distribution. The probability that a randomly selected tree is going to be of a particular species and also of a particular height class divided by the marginal probability that it is in a particular height class. So again, if we want to substitute in some numbers, we've got P 2 given 1 equals P 2 1 divided by P 1, and that's going to give us our 0.22, because probability of being a pine, given that it's in height class 1, is equal to the joint probability of it being both a pine and in height class 1, which is the taller height class, divided by the marginal probability that it's in height class 1. Now we've got a different way to look at this. So what I'm going to do is I'm going to start off with P S given H. Conditional probability is equal to the joint probability divided by the marginal probability. And given that I've got an H here, I really don't need this H here. It should be pretty obvious that we're dealing with heights in the denominator. So I'm just going to get rid of that. And then I'm going to rearrange this and say that the joint probability, randomly selected tree being a particular species and height class, is equal to the conditional probability times the marginal probability of it being in height class. So this is just a rearrangement. And we can think of this intellectually as saying, okay, in order for a randomly selected tree to be a particular species, let's say pine, a particular height class, let's say greater than 170 centimeters, is going to be equal to the conditional probability multiplied by the marginal probability. In other words, it's first got to be in a particular height class, and then it's got to be in a particular species, given that it's in a particular height class. And of course, we could flip that around a bit and say, okay, it's also true that PSH would be equal to P So what we're saying here is the joint probability that's of a particular species, particular height class, it's first got to be in a particular species, and then it's got to be in a particular height class, given that it's in that particular species. So then if we equate these two things, we've got this. And then we can do two things with that. We can say that there's two different ways. We can say that the conditional probability of S given H is equal to conditional probability of height given S times the marginal probability of S divided by the probability of H. Or an alternative way to think about this is that probability of H given S is going to be equal to probability of S given H times probability of H divided by probability of S. And this is Bayes' theorem, which is the foundation of this workshop.